So today is section 4.1, part 2. The end of yesterday, we just started going through how you know if a point is a minimum or a maximum. So we're going to review that really quick, and then we'll try to do just some other types of questions that don't have to do with graphing. The graph might already be there, and you have to write down some information about an equation and things like that. So if you have an equation in vertex form, it gives you information about the graph. So the first thing that you want to look at is, does the graph open up or does the graph open down? The sign that's ahead of it is basically what tells you that. So if the number A, and of course they're only looking at the sign, not the actual number at this point, if A is bigger than 0, that means it opens up. So if A is positive, and you can write that if you want to. I'll write it off to the side here so you have a little note if you look back. Okay, so when it says A is greater than 0, that means that A number is a positive number. It opens up, so the vertex point would be at the bottom of it. So that would indicate a minimum value. If A is negative or A is less than 0, it opens down and that vertex would be at the top part. So that would be a maximum value. So think about what it looks like when it opens up and what it looks like when it opens down. And I think you will get that if we do a few. And if you want to do a sketch of a picture there, that would be okay. This one goes here, this one goes there. So just gives you a little picture of what it looks like.
I need the 9th graders with the last names A through M to head up to the gym for school pictures. Thank you.
Okay, so here's a sample. So they give us an equation. They want us to write down the information that we take from it. So the vertex is always the HK part. Remember that it looks like this. That's the standard form. I just wrote it underneath so that you could kind of look at where we were getting stuff from. The vertex is always the HK. So I'm going to take the 4 out, and the sign goes with the K. Okay, so my vertex would be 4, -2. Remember that the number that's inside the parenthesis, you always kind of have to do the opposite sign of that. It looks like it's a -4 inside, but remember when you take it out of there, it's just the 4. The sign of whatever the K is goes with it. So it's supposed to be a plus. This one's a minus, so the negative does come with it. The axis of symmetry is always whatever that first number is in the vertex. It's always that number. So my axis of symmetry is going to be x equals 4. And then for the maximum or minimum, you decide that 3 is a positive number. 3 is positive. So this one opens up. So would it be a maximum or a minimum if it opens up? Minimum, so it would be at the bottom. So I'm going to say minimum on this one. You don't have to necessarily write any of that stuff that I wrote. The 3 is positive, opens up, but that's what I'm thinking about when I'm doing them in my head. And of course, you wouldn't have to graph this one. That's all the information that they want us to do. I think the translations you guys kind of already know. We'll go through each part, but we kind of understood that, and most people were kind of getting it when we ended that particular section. So when you're looking at the movement part of it, what does this determine, that x minus h part of it? Does it up, down, right, left? It's what? Or left, depending on what the numbers are. So that's the horizontal movement. The vertical movement is this part right here, and that would be up or down, depending on the number. And then if there's both there, like if this is written in standard form or this vertex form, notice that we have both. Right, left, up, down. Okay, so if it's written in a vertex format, you would have both of them together. I'm not really paying attention to what this vertex becomes because I think you can figure it out when you're graphing and when you're, looking at it. So I don't think that's going to be a problem at all. I think it would be more confusing if we did it that way. So use the vertex form of the quadratic function. Stretch or compress by the factor of absolute value of a. Remember, the number in the front is always the stretch or compression number. Just to review, it's a stretch if a is bigger than 1. It's a compression if a is between 0 and 1. Fractional number. It could be a fractional number and still be bigger than 1, so I don't want to just say fraction, but if it's a little fraction between 0 and 1, then it would compress down. It's always the absolute value of a there because the negative and the positive sign ahead of it determine if it opens up or down. It doesn't have anything to do with stretch or compression. If it's negative, it goes from the parent function and it flips it down. And negative also means down, so that I don't think you have to really pay attention to. The units that you're shifting, you guys already know how to do that, so I'm not going to look at that again. All right, so I guess this one is a graphing one. I think I changed the question in the book, actually, so you don't necessarily need a bunch of graph paper, I don't think, for the assignment, but let's look at this one so we can review each of the parts. So if you do need graph paper, you can go and grab some. And if there isn't any, let me know. Okay, I hate when it does 2 pages. There we go. Okay, so I'm going to do the parent function this time, and then we're going to go each of those numbers from there. The parent function makes it easier to do the stretch or compression part, I think, but you don't necessarily need it. I just think it's helpful. So the parent function would be the parabolas that you guys did yesterday, 0, 0, 1, 1, 2, 4. I'm only going to do those points. I'm not going to do the 9 one this time, the 3, 9. Unless it tells us we need to, but I don't think it does. So here's my parent function. So what does the negative mean? The negative before the 2? Down. Okay, so it opens down. I'll put opens down. Okay, what does the 2 mean? Is it a stretch or compression? So the stretch, the y units would be 2 times bigger. Okay, I'm going to go y unit times 2, just so I know that that's what I'm going to do here in a minute. What does the x minus 1 mean? Right 1, so it's the opposite sign, so I'm going to move it right 1. And then what about the plus 3 at the end? Up 3. So we're going to be moving this kind of all over the place. I'm going to do just parts of it. I'm not going to do like 5 different graphs like we did that day, but I am going to do the graph of the stretch and the down. and then we'll kind of we'll move the right one up 3 kind of at the same time. Okay, so I'm going to change colors here. If it opened down, we could just flip it directly where it is. I like to do the flipping right away because then you're not wondering where it flips over. Right now it just flips the other way, and you can think of it like that too. When it opens down, take it from where it is, that vertex point stays where it is, all the other points move the other direction. So I'm going to do that first. So this one stays and the others flip down. So if it's 4 units away from the x-axis, then it would be 4 units away from the x-axis the other direction. So here's the down part. Then I'm going to do the stretch part, and then we'll move it a couple times without, graphing each part. So when I do the stretch part, we're going to look at the y units, and we're going to take them times 2. So 0 times 2 would stay where it's at, right? The y values for these next 2 points, is -1. If I multiply that by 2, what do I get? -2. Okay, hold on. Let me think about that one. Yes, the x stays the same. So it was at -1, now it's at -2.
Is this for me to make, like, in essence, when we're doing to make, like, a little value?
You can do a table, yep. And then the y values for the next 2 points down are at 4, but when we multiply them by 2, what do we get? 8. So I don't know if I have enough room. 1, 2, 3, 4, 5, 6, 7, barely. Yep, I do. Okay. 1, 2, 3, 4, 5, 6, 7, 8. And 8. So remember that when you are doing a stretch, it goes inside the curve that's already there. If you're doing a compression, it kind of goes outside and makes it like flatter instead of stretchier. Now, if you can do that part, the rest you can do at the same time because we're going to move it right 1 and up 3. So we can do each point right 1, up 3. Okay, so I'm going to change colors one more time. We'll go with pink. Okay, so the 0, 0 goes, and you can do right 1, up 3, right 1, whichever you want to do first. Right 1, up 3. So I'm going to go this point, right 1, up 3. Right 1, up 3. Okay, so my pink one there is my final answer. I think when we were doing these the first time, most people wanted to go, I'm going to go right 1, up 3 first because that's the easiest part. But I think starting with the hardest part is actually easier to get those tough points done, because if you move it and your y values are not the same as they were at the beginning, so when you multiply them by 2, it just makes it a lot harder to do. So I think doing the A number in the front and then the positive or negative first helps a lot if you have to graph it. Sometimes you won't. Okay, did everybody get that? Sorry if I'm moving too fast. Okay, so what are the transformations of this one? So just like we did on the last one and then we graphed, we're just going to say what these transformations are. So I'm going to do each part just like we did on the last one, and just talk about what each part means. So the first thing I'm looking at is, what does the negative mean? Okay, so it is opens down. And when we looked at our transformations, we would call that reflect over the x-axis. Okay, here it's parabola, so we can just say opens down. What about the 2? Yep, vertical stretch of 2. And I'm going to say because 2 is, a is bigger than 1. That's why we did that. What does the x plus 1 mean? Left 1. And what does the plus 3 mean? Up 3.
What does it mean by opens?
So when you're looking at it, we don't do parabolas opening right left. It either opens up like this or down like this. So basically the opens up is from that vertex point that we have.
It's just like a flop.
Yep. And then the opens down just flips it down.
Okay.
Yep. So if you had to describe it, I think we would all be pretty good at that now, right? Because we did that quite a few times. So really what they're looking at is this part. But if you want to do it kind of like I did and do each part and write what it is first, that works. Okay, this is the last one. It has a picture, so I just copied it in here. It's the jump of a dolphin. What quadratic function models the path of the dolphin's jump? So you're going to have equations where you're going to have to write each part in. Okay, so I'm going to make this a little bit bigger so that we can see it better. And I'm just going to go from right there. Okay, so if you can, try to figure out where that top is. Where is the vertex part of it? Where would the axis of symmetry be? Those kinds of things. So what we're going to be doing is putting in numbers to this equation. So when I'm looking, it to me looks like the vertex is right here. Is that where you guys are thinking it is? Because you're looking for that point where if I folded it in half and actually put this axis of symmetry in there, would it look the same on each side? Okay, so that point is 3, 7. So where do I put those numbers in? H and K. So here's what it looks like so far. Now, for this one, it's going to be pretty hard to figure out what that A is. And on some of these, when the numbers are big and you don't have a graph, here's what you do. I'm going to actually keep the A where it's at. And is it a positive A or a negative A this time? It's opening what direction? Down. So it would be negative. I'm going to actually put a negative there. Here. I'll put that in a second. It just looks weird up there. But we do have a bunch of ordered pairs, right, that we could use for X and Y. So what we're going to do, instead of doing like a slopey kind of thing, we're going to plug an ordered pair in there and find the A number, which I think for most of us is probably going to be easier. So I'm going to pick a point that I know for sure what it is, and there's lots of them that you can use. I am looking at, I think this one. I think it's this one right here. Did the book use 10-3? 9-4, let me see. Okay, let's do that one instead. I just couldn't tell, it kind of got light over there. It is just a little bit under that. So you want to find a point that you know exactly what it is. So we're going to use 9-4. The 9 is going to go in for the X. The 4 is going to go in for the Y. So it looks like this. 4 equals negative A, since I know it opens down. And then my X is 9. And what I'm going to do is just do a lot of simplifying and find out what my A is. So it looks like this. 4 equals negative A. 9 minus 3 would be 6. 6 squared is 36. Don't put those two together because they are being multiplied. So 4 equals negative 36A plus 7. I solve for A, so I'd subtract 7 from both sides. And then I'm going to divide by negative 36. So A equals 1, what is that, 12? Now, the only thing is, I put the negative in right now, so when I write my equation, I need to keep the negative there. If you don't do the negative, I think it would turn out to be the sign that you need. So I don't know what's easiest for you guys. You just have to pay attention at the end. Did my equation turn out like it should? So now I'm going to rewrite it. It looks like this. So I should put that in there. Okay, I'm kind of basing it off of this one right here. Okay, so y equals, since there's a negative there, I'm going to go negative 1/12 x minus 3 squared plus 7. I went the little one that I put in the little box, and I did add my negative back in there.
Okay.
For you guys, I think it would be easier just to plug the number in and let it do its thing. Okay, so if you didn't have your negative up there, you would have had a positive on one side and a negative on the other, and it would stayed negative. You wouldn't have had to decide, but you should be able to look and go, you know what, this opens down, I know it has to be a negative, I'm going to put it in there. So it kind of works either way. And that's what they're looking for. Now, could you have done that using slope? Let's check it out. These are in ones. 1, 2, 3. And 1, 2, 3, 4, 5, 6. That doesn't really work on these. So it has to be more of the absolute value ones where your line is diagonal, or you know it's a line, so you can't really use slope for these. And I think that was it. So when you come up with an equation, double check that number at the end. If this is opening down, it should have a negative there. If it is opening up, it should be a positive there. So just be careful with the sign of that last number. Quiz tomorrow on 4.1. I haven't decided if I'm going to put a word problem on there or not, because I really haven't written it, but it won't be very different from the ones that you guys have done. So keep in mind the ones you did yesterday, if you thought those were easy, there's not going to be 8 of them on the quiz that you have to graph. So it's maybe a few graphing, but not over the top.